So here we are solving the question union of two sorted arrays with duplicates. So here in the question they have not written the word array, that word is skipped, but here it should be union of two sorted arrays with duplicates. So what this means is that we will be given two arrays, array A and array B, and we need to find the union of those two arrays. Now, what is union? In mathematics, in schools, we have studied that union is basically the unique elements from both the arrays. So the elements which are duplicate, which are present in both of the arrays, we just do not count them twice. We just write them once. So that is basically union. Write all the elements from array A, write all the elements from array B, and make sure that the duplicate elements are only written once. So that is union. Now, after reading this question, the first method which came to my mind and which would come to yours as well is to use a hash set, because that is the exact property of hash set, that it does not allow duplicate elements. Yeah, right. But you see that no DSA question is this much straightforward, that they just give you what to use, and they just give you the directly, they tell you that you have to do this to get the result. No question is such as straightforward. And when you look here in the expected complexities, it says O of 1, which is constant space, and that confirms this suspect, says this suspect, because if you use a hash set, then auxiliary space will be theta of m plus n, where m is the size of array A and n is the size of array B. But here we have to do in O of one auxiliary space, that is a constant. So we need not use any extra space. So which is why we move towards a different solution. Now, this is the solution, this is the method which I have used. It is similar to the merge function in the merge sort. So in merge sort, the merge function that we have, or merge method, I should say, since we are talking in Java right now, it is similar in working to that merge method. Now here, if we do look at the code, then the first thing that you will see is that the parameters which are passed, we are only passing the array A and array B. And this is because in Java, the arrays are objects, and the length of the array, the size of the array, is a property of that object. So we need not pass that along with the arrays as in the parameters or a function, something that we would do in C++. But here in Java, there's no need for that. Then here I have written int n1 assign a dot length and int n2 assign b dot length. Then why is this so? Like if I already have that property of array that it has the length as a parameter, then why have I taken the length into a separate variable here? The reason for this is when we're checking down here in the while loops, this loop, this loop, this loop. So if you just write here I is less than a dot length, then for every iteration of the loop, a dot length that will need to be calculated, and that takes some extra time. But if we take that value in an integer, in a variable, and we directly write that here, so that basically that step of computation and the getting of the length of the array, that step in every iteration, that is skipped, hereby thereby saving us some of the time and resources as well. So that is the reason where I have taken the lengths in two separate variables. Now here for we have to return the an array list. We could have you could have also written it simply list like this, but I have considered but I have written it array list since I'm sure that we have taken array list only, so I have declared it like that. Then I and j, these are loop variables, and these variables basically I is used to traverse the array A and j is used to traverse array B. Now, why have we written it outside of the loop? Because normally, if you see the loop counter variables, we write it inside of the loop along with the declaration part. Then why have we written it outside? The reason for that is because these values of I and j, I will be using it here as well, here and here. So if I would write it inside the loop, then its scope will be limited to this particular block of code only. And so I would not be able to use their value uh, once I come out of this loop, which is, and that is why I've written outside the loop. So now the scope of these two variables is the scope of this function, entire function. So that's that. Then, then here in the while condition, this is written I is less than n1 and j is less than n2. This is to make sure that we are traversing both the lists simultaneously. Because what we need to do is we need to compare the elements of both the arrays and then accordingly put them in ascending order. So to make sure that both the lists are being traversed simultaneously, I have this condition has been put that I is less than n1 and j is less than n2, because until and unless this condition becomes false, we'll be traversing both the lists simultaneously. So these first two if conditions, what they check is that the current element is same as the previous element, because see, we have to consider that element of the current array is not same. If it is, it should be unique. It should not be the same as element of the other array. But it is also possible that that the same array has a multiple has the same element written multiple times. For example, here if you see, we have one written 5 times. Here we have two written 2 times. So the same array can also have the same value written multiple times. So this if condition checks that. So this is for the array A, that if that while I is greater than if I is greater than 0 and uh, I of minus 1 means the previous index element is same as the current index element. In that case, just increment the pointer and continue. What continue does is it tells that skip rest of the statements of this particular loop and go to the next iteration. So it directly jumps to the next iteration. Similarly, this if condition does that for the other loop, which is the B loop. So these two if conditions check for this, that if that the current element should not be the same as previous element. Now moving ahead. Now this part here is very similar to the merge method in the merge function, which is that if the element of array A is less than element of array B, simply add the element of array A to the resultant array list and move ahead. So here, move ahead, I have written it I plus plus here itself. So now this is post increment, meaning that first this particular operation will be carried out and then this particular operation will be carried out. I could have also written it like this, but to save space, like this, but to save space, I have written it that way. Similarly, for here as well, I have written it this way just to save space. By no means this is the correct way syntactically. This is not a very good way to write your code. It makes it much more complicated. But to save space here, otherwise I'll need to keep scrolling it back and forth. I have written it this way. This is not a good way to write your code. But here it is very well possible, and it's not a bad practice to write like this. So moving ahead, else if the element of array A is greater than element of array B, then add the element of array B and increment the B pointer and increment the pointer of the B array. And else, this else basically checks for the condition that if A of I equal B of J. This condition is checked by this part. You could have also written like this, else if, and then this way. But since no other condition is true here, like this is only what is left, therefore I have chosen to simply write here else. Because again, if I would have written it this way, then it would first check for this condition and then move ahead. And this way it would directly move ahead with this. So that condition checking, that also takes some time, which adds to our time complexity. Although all these things are very minimal, they're very small, but still, if it's possible in our hands to optimize our code, we should definitely optimize it. Which is why I've directly written here else. Now else, if this condition is true that both the elements are same, then in that case simply add the element and increment both the pointers. Now here I could have also done b of j, because it doesn't matter since both the elements have the same value. But since array A is coming first, therefore I've written array A and then increment both the pointers. Now what happens is that now what will happen is that this will keep on executing, and after one such iteration it will come that one list will be completed because both the lists are not equal. And so it will be happen that at a point a particular array is completed, all the elements have been traversed and the elements of the other array are left. You can also dry run this yourself to better understand what I'm saying. Because so for example, if you look here, then the last element of this array is 5, and the last element of this is 7. Now, while the ith pointer is here, the j pointer will be here. And so after this one, I plus plus, and then this goes out of bounds. And so the traversing of array A is completed, but still two elements will be left in array B. So this particular condition that is taken care of by these two if blocks, these two while blocks. So this particular is for if elements are left in array A, then this while block takes care of it. If elements are left in array B, then this while block takes care of it. Now, the same thing that while I is less than n1, considering that elements are left in array A, array B is traversal of array B is complete. Elements are left in array 1. So I would also write, should also write here that uh, array B is complete, traversal of array B is complete. So array A elements we are taking care of here. So while I is less than n1, and then this condition. So this is basically the same what I have written here. It's just a copy paste to check that the current element is not same as previous element. Then simply keep on adding the elements, because once the array B traversal is complete, then I need to just add the elements of array A. And since in the question it is written sorted arrays, therefore the elements of array are sorted, and I can directly add them. No need to check for any condition or anything. I can directly add them. And this is exactly what I have done here. Similarly, if array A traversal is completed first, that is elements are left in array B, then this while condition will not be checked. This while condition will not be executed. This condition will fail, and this loop will not be executed, and the control flow will come to this loop. And this loop basically we can write here again. Traversal of array A is complete. So while j is less than n2, and so this is just the same as this one, but just for array B. And after this, what will happen is that our resultant array list will have both the elements from both the arrays, the unique elements from both the arrays, in a sorted manner, in a non-decreasing manner, non-decreasing, no, in an ascending order, because here non-decreasing also is wrong, as only unique elements are there. So like this, our resultant array list will have all the elements in an ascending order, all the unique elements in the ascending order from both the arrays. So here, if I do submit, then you can see that it runs. So initially it takes some time for the initial test cases, then it goes through very fast, and then towards the end as well, it again takes some time. So we'll let it happen, and all the test cases are passed. And just so basically this accuracy is because yeah, I also was testing again and again, which one is correct, like what optimizations should I do and how should I write my code. So initially my code also failed for all the test cases, which is why total of 10 attempts I have taken. But this is something that can be improved in practice. As you practice more and more, you will get better results. And if it's fewer attempts, your code will pass all the test cases. So thank you.